Good morning, everyone, and thank you for being here today. I am pleased to welcome you to this presentation on a comprehensive approach to batch reconciliation in semi-solid dosage forms. My name is Dr. S.K. Singh, and I hold a PhD in this field. Today, we will explore strategies and best practices to ensure accuracy and consistency in batch production. Over the next few minutes, I will walk you through key concepts, challenges, and solutions related to this important topic. Let's get started. Let's talk about batch reconciliation, which is essentially a complete accounting of all the materials involved in a production process. It's a crucial step to make sure everything lines up correctly. This process helps us prevent losses, mix-ups, or even contamination that could compromise the quality of the final product. Full traceability is another key aspect, meaning we can track every material throughout the entire process. This is especially important for semi-solid products, which are more challenging to handle due to their high viscosity and tendency for adherence losses in equipment. And it's worth emphasizing that batch reconciliation isn't just good practice. It's mandatory under CGMP guidelines before we can release a batch. This ensures we maintain the highest quality standards and regulatory compliance, ultimately protecting both the product and the end user. Now, let's take a look at the stages of reconciliation in our manufacturing process. First, we start with raw material dispensing, where all the ingredients are carefully measured and prepared. Next comes bulk manufacturing, which involves mixing and emulsification to create the desired formulation. After that, the product is filled into tubes or jars, ensuring precise dosing. Then, the packaging stage involves adding labels and cartons to protect and identify the product. It's crucial that each of these steps is verified and approved by QA to maintain quality and compliance. Moving on to the scope in semi-solid manufacturing, we're dealing with products like creams, which can be oil in water or water in oil, ointments, gels, and pastes. These products are complex because they are multi-phase systems, making material tracking more challenging. Additionally, they often contain a high percentage of excipients, sometimes up to 90%, which adds another layer of complexity to their manufacturing and quality control. Understanding these key stages and challenges helps us appreciate the importance of rigorous processes and oversight to ensure product integrity from start to finish. Let's take a closer look at the material balance equation, which is fundamental in our process control. The core idea here is that the material issued to the process must be fully accounted for. This means that the material we start with is either used in production, wasted, sampled, returned, or lost. Every single gram counts, no estimations are allowed, so accuracy is key. Now, moving on to yield calculation. The formula is straightforward. Yield percentage equals the actual output divided by the theoretical output, multiplied by 100. The theoretical output is based on our batch formula, which tells us what should be produced under ideal conditions. The actual output, on the other hand, is what we measure during production, whether it's bulk or fill. Why is this important? Because calculating yield helps us detect process inefficiencies. If our actual yield is lower than the theoretical, it signals that something might be going wrong. Maybe wastage is higher than expected, or there's an issue with the process itself. By monitoring yield, we can identify areas for improvement and ensure our process remains as efficient and consistent as possible. In the filling stage, we start with a bulk available of 96 kilograms, and each tube is designed to hold 20 grams. Now, if we do the math, dividing 96,000 grams by 20 grams per tube, we expect to fill around 4,800 tubes. In reality, we actually filled 4,700 tubes. We had some rejects, about 50 tubes, plus 20 sample tubes for testing, and an additional residual loss of approximately 30 grams. When we add everything up, filled tubes, rejects, samples, and residuals, it totals back to our initial bulk of 96 kilograms, confirming that our reconciliation balances out. This process highlights the importance of tracking actual yields versus theoretical ones, which is common in manufacturing. For example, in bulk cream production, if we start with 100 kilograms, but only get 96 kilograms after mixing. That's a 96% yield. The 4% loss can be attributed to factors like vessel adhesion or transfer losses, which are especially common with semi-solid products because of their viscosity. Understanding these losses helps us improve efficiency and ensure quality control throughout our manufacturing process. Let's take a closer look at the acceptable limits in our industry. Typically, the limits we see are around 3 to 5% for bulk loss, meaning that during production, losing that amount of material is considered normal. For filling loss, the acceptable range is usually between 1 and 3%. And when it comes to packaging variance, a tolerance of plus or minus 0.5% is generally accepted. These limits are not arbitrary. They are based on process validation and historical batch data, which help us understand what is realistic and achievable without compromising quality. Now, to illustrate this, let's consider an example of raw material reconciliation. Suppose we start with 5 kilograms of active pharmaceutical ingredient, or API. We measure that 4.8 kilograms were used in production, with a small sample taken of 0.05 kilograms. The loss here is 0.05 kilograms, probably due to minor process inefficiencies or sampling. Additionally, 0.1 kilograms are returned, perhaps from excess or waste. To check our calculations, we add up what was used, the sample, the loss, and the return. 4.8 plus 0.05 plus 0.05 plus 0.1. And that equals exactly 5 kilograms, confirming our reconciliation. Finally, it's important to remember that this kind of reconciliation is required as per our SOPs, especially for products like creams, ensuring consistency and compliance throughout our process. Now, let's take a closer look at deviations and investigations. First, we need to be alert to certain triggers that indicate something might be off in the process. For example, if the yield goes outside the predefined limits, that's a clear sign we need to investigate further. Missing material is another critical trigger, as it can point to issues in handling or recording. Excess gain, which means more product than expected, also warrants attention. When any of these triggers occur, our actions are crucial. The first step is line clearance verification, to ensure the production line is properly cleaned and prepared before resuming operations. Next, we do a reconciliation recheck. This is about verifying all data and materials to identify discrepancies. And of course, we conduct a thorough root cause analysis, or RCA, to understand exactly what caused the deviation so we can prevent it from happening again. Remember, before releasing any product that might be affected by these deviations, QA approval is mandatory. This step ensures that all quality standards are met and that the product is safe for consumers. Overall, these processes are essential for maintaining quality and consistency, and they tie back to our overall goal of delivering safe, reliable products through diligent monitoring and investigation. Let's talk about documentation in GMP, which is absolutely essential for ensuring product quality and compliance. First, we have the key records that need to be maintained: the batch manufacturing record, or BMR, and the batch packaging record, or BPR. These records document every step of the manufacturing and packaging processes, providing a complete history of each batch. Then there's the reconciliation sheet, which helps verify that all materials and components are accounted for throughout production. And finally, deviation and CAPA reports, which track any issues that arise and the corrective actions taken to resolve them. It's crucial that all these records follow the ALCOA plus principles, meaning they are attributable, legible, contemporaneous, original, accurate, complete, consistent, enduring, and available. This ensures the integrity and traceability of all documentation. Real-time documentation is also key. Recording data as processes happen reduces errors and enhances data integrity. Overall, thorough and compliant documentation supports not only product quality, but also regulatory inspections and audits. It's the backbone of a robust quality system, helping us demonstrate that we manufacture safe, effective products at all times. Let's talk about some of the challenges we face with semi-solids. One common issue is adhesion to vessel walls, which can affect the consistency of our product. Transfer losses in pipelines are also a concern, as material can stick or be lost during movement between equipment. Sampling losses pose another challenge, since it can be difficult to obtain representative samples without losing material or altering the sample. Phase separation is also something we need to watch out for, especially in formulations where different components tend to separate over time. Lastly, mixing and shear conditions can impact the uniformity of the product, making it essential to control these parameters carefully. Now, to address these challenges, there are several mitigation strategies we can implement. Using scrapers inside vessels helps prevent material from sticking to walls and ensures better mixing and transfer. Closed transfer systems are crucial for minimizing material loss and contamination during transfer processes. And of course, validated cleaning procedures help recover residual product and maintain cleanliness, which is especially important in meeting quality standards. All of these measures are part of a broader effort to improve process robustness and ensure the quality and consistency of semi-solid products throughout manufacturing. In conclusion, reconciliation stands out as a critical tool for GMP control. It helps us ensure several key aspects of our manufacturing process. First, material accountability, making sure every raw material is correctly tracked and used appropriately. Second, batch consistency, ensuring each batch meets our quality standards and is uniform. And third, regulatory compliance, making sure we follow all the necessary guidelines and regulations. When we combine a strong SOP with accurate calculations, it creates a culture of manufacturing where discrepancies are minimized or even eliminated. This zero discrepancy mindset is essential for maintaining the highest quality standards. So, reconciliation isn't just a check, it's a vital part of building trust in our processes and delivering safe, reliable products. For further support, please don't hesitate to reach out. If you have any questions or need additional information, I'm here to help. You can contact us through the provided channels. Thank you so much for your time and attention today. We truly appreciate your interest and engagement. Remember, we're always available to assist you as you move forward with these concepts. Again, thank you, and I look forward to connecting with you soon.